Hello, my name is Vedant and today we will discuss AtCoder round 449 beginner contest. So let's start with the first question, that is pi. You are given a positive integer d and find the area of a circle with diameter d, and d is up to 100. So this is a pretty straightforward question, right? All like we are given d and we need to find the area of circle. So it is pi d square by 4, right? And this is our answer. So let's check the code. So we are taking the input and then this m underscore pi is actually a compiler constant, and as you can see that this stores the value of pi up to few decimal places, right? And then we are multiplying it by n square and dividing by 4. Like you can see that it is defined, right? And then we are asked to print the answer up to like 6 decimal places should be correct, right? That your answer is considered correct if the absolute or relative error is at most 20 minus 6, right? So what I'm doing is I'm just printing it up to 10 decimal places to ensure that. So that's it for the first question. So let's move on to the second question. The second question is deconstruct chocolate. So there is a rectangle chocolate consisting of H rows and W columns. You are given Q queries and process them in order and find the answer to each query. Each query is one of the following format. Type 1, an integer r is given. Find the number of chocolate blocks in the bottom r rows and eat them. And in type 2, similarly, c is given and we are eating the rightmost c columns. And when the queries are processed in order, the chocolate remains rectangular after each query is processed. I mean, definitely, since we are eating up entire rows or columns, so it will definitely still maintain a rectangle. And it has at least r plus 1 rows immediately before processing a type 1 query and c plus 1 columns immediately before type 2 query. So this just ensured that after each query, some portion of chocolate is still left, right? H and W are up to 100 and Q is also up to 100. And yeah, let's check the first case. So in the first case, we are given a block of 7 cross 9, right? So it has 7 rows and 9 columns, right? So yeah, let's do the second question. So let's say 1, 2, right, this is 7 rows and these are 9 columns. And in the first query, we are doing a query of type 2 and that is we are eating 4 columns, right? So we are eating this column, we are eating this. Actually, let's use another color for this. So let's use a highlighter. Okay, never mind, it is not visible. Right, so we are eating, this is the first column, this is the second column, this is the third column, this is the fourth column, right? So basically these are 4 columns or and the like entire row and the number of elements in each column are the elements in a row, that is 7. So basically the first answer is 28. Then we are eating 3 rows, right? So now we are eating these 1, 2, and 3 row. So as you can see that initially what were our value of H and W, right? Our H was 7, W was 9. After we ate 4 columns, it reduced to 5, right? We can notice that there are now 5 columns per row, right? And now we are eating three rows. So again, what is this value? This is again 3 into 5, that is 15. And now our height is reduced by 3, so our height is now 4. And now we are eating one column, right? So when we'll eat one column, now again, this is nothing but our height was 4, right? So this is 1 into 4, that is 4. And now height is reduced to 4. Now again we are eating one column. So again this is 1 times 4 is 4, and our height is reduced to 3. Width is reduced to 3 now. And now we are doing a query on row, and we are eating 3 rows, right? So that is 1 row, 2 row, and 3 row. We know that each row has 3 elements. So this value is now 3 rows into 3, that is 9. And our rows are reduced to 1, right? So basically, what we can notice is we have two types of queries, right? Type 1 query. In type 1 query, our answer is added by W into R, right? And our H is reduced by R. And in type 2 query, our answer is increased by similarly by H into column, and our width is reduced by column, right? And finally, we are just printing answer for each of them. So this is basically our question 2 and the two types of queries. We already noticed that we are getting all the answers correct for this. So let's test the code now. So in this code, we are basically taking three inputs, height, W, and queries. Now for each query, we are taking T, that is the type of query, and the dimension, whether it is row or column, whatever is the value of that dimension. So for the type 1 query, as we noticed, we are adding the answer by W into dimension, and we are decrementing H by the same value. In the second one, we are just replacing W and H, right? And we are printing the answer in each of them. So this is our second question. So now let's move on to the third question. So the third question is comfortable distance. You are given a string S of length n consisting of lower English letters. Find a number of pairs I, j satisfying the following condition. So our I and j are from 1 to n, our j is greater than or equal to I. Si and sj must be equal, and also the difference between j and I must be between L and R, right? Our L and R are from 1 to n minus 1. Right, so we need to count number of such I and j pairs such that their distances between L and R, and both of these indices have same values, right? So what are the constraints? The n is up to 5 if 5, and that's all. You can see the test cases as well. So let's check what exactly is happening in this problem. Right. So basically, let's say we are at an index j, right? Suppose we are suppose we have multiple indices here, right? And we are at index j. Now we know that when we are at index j, we will check all I such that Si is equal to Sj, and answer plus equals to number of I such that j minus I is less than equal to R and greater than equal to L, right? This is basically what we need to do. So let's say we are like what are our possible values of s? We know that the string s consists of lowercase English letters, right? So basically number of possible values are 26, right? So let's say we have created a like we have created a map and it is that map is storing the indices for all of these values, right? Like A comes on which all indices, B comes on which all indices, and so on, right? So let's say we are checking for S of I, right? S of J, right? So let's say it currently has some indices I1, I2, I3, I4, I5, I6, and so on, right? Now, since we are doing a loop from 1 to n, basically these indices are also inserted in that order only, right? In all of the elements. So these indices are all in the ascending order, and basically like j minus I1 is definitely greater than j minus I6, right? We already know this. So the I6 is pretty much the nearest point to j, right? So it is possible that, let's say, j minus I1 is greater than R, j minus I2 is now less than equal to R, and similarly, maybe j minus I5 is less than L, right? So if this is the case, then what we can say that our I2, I3, and I4 are valid indices, right? Why? Because this is beyond R, this is too far away, and I5 is too close. Since I5 is too close, I6 will also be too close, right? So basically, if we can just find the two endpoints, can we find the number of indices? And how will we find these endpoints? Now, what will the lower bound give us? Lower bound on this, like on SI, like dot begin dot end. Right, I'm not writing that part. And on value, j minus I, right? Not j minus I, my bad. It is j minus R because this will give us the farthest value, right? And since this lower bound will lie somewhere here, right? Because this is too far away. This value will come out to be less than that. Our lower bound will give us values that are greater than equal to it, right? So this is basically our lower bound for j minus r, right? And this will give us all these five values, right? Similarly, let's say we do upper bound for again si values, and this time we do j minus l. Now what this will give us? This will give us all the values that are greater than j minus l. That is, they are too close. So again, this will lie somewhere around here, and this will give us these two values, right? This is our upper for j minus l, and basically, let's say this is 1 and this is 2. So isn't our answer just 1 minus 2? And we can do this for all I, right? Because this is giving us all the values that are closer than R, and this is giving us all the values that are closer than L. So difference of that is values between L to R, right? So that's the question. And the main point was that even if we are storing all the indices and if we check them one by one, so it will go up to O of n square. So to reduce that O of n square to O of n log n, what we are doing is instead of checking it linearly, we are checking it using binary search kind of thing, using lower bound, right? So let's check the code. We are given n, l, and r and the string. Now we have made a vector that is storing the frequency of all these values. Actually, it is not storing the frequency, it is storing the indices where all these values occurs, right? And now we have initially answered as 0 and we are doing a loop. Now for this ith value, what we are doing is we are calculating the answer. And after we have calculated the answer, we are inserting this value into our vector, right? F of Si is again a character. When we are subtracting a with it is giving us some value between 0 to 25, right? That's what we need. And then we are pushing the value I there. Now basically what this S of I was basically this only, right? F of Si minus A. Then we are doing a lower bound on this that is from begin to end and doing it with I minus R. So basically this is giving us all the values that are all I closer than our distance, closer than or equal to. And this is giving us all I closer than L, right? Or adding all I and now we are subtracting these, right? So this is basically our answer for this question. And we have effectively reduced the complexity from O of n squared to O of n log n using this trick, right? So let's move on to problem number D now. There is a two-dimensional coordinate plane. A lattice point with coordinate x, y is painted black if the maximum value of mod x and mod y is even, and white if it is odd. Among the pairs of x, y satisfying x is between L and R and y is between D and U, find the number of those points x and y painted black. Now our L and R are from minus 26 to plus 26. Similarly, D is also from minus 26 to plus 26, right? So we are given two test cases, and for one test case, they have given us the diagram. So actually, the main diagram is kind of independent of the input, right? This is just creating the blue box, and then we are counting the red values, right? But can we notice something here? What exactly we are taking? We are taking the values of maximum of mod x or mod y when they are even, right? Those values are turned into black. Now, can you see that the black values are pretty much forming a square, right? And why exactly is this happening? Because, like, the vertical lines. These vertical lines represent the values where mod x is greater than equal to mod y, right? And horizontal lines represent the values where mod y is greater than equal to mod x, right? And they're definitely overlapping at the values where the mod values are equal. That are the corner points, right? So let's see how we'll calculate this. First of all, we can't go to each separate value and check for this because, come on, how many values are there? L and R are from minus 26 to plus 26. So basically, possible values of x are 2e6 and possible values of y is also 2e6, right? So it is basically NC2 type of, not even NC2, it is N squared. That is 4 equal possible coordinates, right? We can't check all values. So instead, we need to do something better. Now, let's say, first of all, this is what this was problem number D, right? Yeah. So this is problem number D. Now we need to count values where maximum of mod x comma mod y is even. right? So actually we can divide this into two parts, right? First of all, mod x is greater than mod y, and the second is mod x is less than equal to mod y, right? Actually, let's handle both of these cases separately. So in the first case, let's consider mod x is greater than mod y, right? So basically, what are the possible values of y, right? Then y can go from minus of mod x plus 1 up to mod x minus 1, right? Or basically, let's say this value is r and this value is l. So our number of values are r minus l plus 1, right? And what we are actually doing is we are putting r and l as this, right? Or let's not use r and l because it was in our input. Let's do something else. Let's say this is our maximum value and this is our minimum value, right? So basically what we are doing is we are doing maximum value minus minimum value plus 1. This is basically how we count the number of values in a range, right? But we have a constraint on, like we have a constraint, right? What is our constraint? Our x is between L and our y is between u and d, right? So actually the value of y also goes from u, u plus, sorry, d, d plus 1 up to u minus 1 and u, right? So can we say that actually the maximum value is nothing but minimum of these two values and minimum value is nothing but maximum of these two values, right? So can I say my maximum is nothing but minimum of mod x minus 1 comma u, and similarly my minimum is nothing but maximum of negative of mod x plus 1 comma l. Like we do get the point of mod x minus 1 and negative mod x plus 1, right? Because we are not taking the same value, we are taking the value less than that, right? And here also the thing is that y could either go up to u or up to mod x minus 1. So y can only go up to which of them comes first, right? And similarly for the lower limit, which of them comes last, right? That's why we've taken minimum maximum. And now again, our number of values, right? Or to say answer is nothing but plus equals to max minus min plus 1, right? Now what do we know? We know that our value possible values are x of x are up to 2e6, right? Yeah, the possible values of x are up to 2e6. So basically, what can we say is that this whole process is pretty much of what? If we calculate the exact value, then it is r plus l, or again the range only, right? Of r minus l plus 1, which is basically O of 2e6 in the worst case, right? And we have only done the first case, right? We had two cases. Now let's solve the second case. In this one, we have mod x less than equal to mod y, right? Or we can say our mod y is greater than equal to mod x. So just like we did earlier, now what we can say is that for a value of y, our x can go from negative of mod y up to positive of mod y, right? And x is also constrained from L to R, right? So again, what we can say is that the maximum value is nothing but minimum of these two values, and minimum value is nothing but maximum of these two values, right? And again, answer plus equals to max minus min plus 1, right? And again, for this also the complexity is same only. It is O of what? Up minus down plus 1. And the worst case is again O of 2 is 6. So it is basically O of 4 is 6, right? Or you can say, right. And this will definitely work. We can do almost 108 queries in 1 second, right? Like 108 is not a very safe number, but yeah, we can definitely do these many queries, right? So basically what we are doing is we are just checking for all, we are dividing it into two cases and then we are checking all smaller values of y for a given value of x, and again the same case for y, like all smaller values of x for a given y. Now there's one more thing we know, right? Both of these values, right? This is greater than equal to 0, this is also greater than equal to 0. And so what we can say is that we can also take a maximum here with this value and 0, right? And same here, maximum with this and 0. Okay, my bad. Actually, let's say just for some reason we get this value as negative, right? Now the thing is in each of the query, this value should be positive, right? Should be positive. And same for this, right? So basically what I am saying is that in all steps, answer is nothing but maximum of mx minus mn plus 1 comma 0, right? This is basically our answer because we are not adding a negative value for any case. If we are not getting any value, it basically means that the number of values for this particular one is 0, right? So this is it for our D question. So let's check the code now. So yeah, we have taken the input LR, D, and U and the answer variable. Now again, if mod x is greater than mod y, count the y between maximum minus mod x plus 1 comma d to minimum of this, right? And if mod x is less than equal to y, then count x between this. This is exactly what we have done. And for L2R, our count is R plus L minus 1, and count cannot be negative. So what we are adding is like maximum of count comma 0. So again, now like we are doing this, but like for this case, mod x need to be even, right? Because that's when we are counting. Similarly, for the second case, mod y needs to be even, right? So basically what we are actually this also reduces our queries from 2e6 to 1e6 only, right? And but the thing is it is just a constant factor. So this is basically O of 1e6 only, right? So that doesn't matter. So what we are doing is we are looping on this, and what it does is it is if the value of L is odd, like if L is odd, then L and 1 is 1, then L plus 1 becomes even, and if L is even, L and 1 is 0, then L is again even. The same is done for Y. And now what we are doing is we are taking a max with 0, and this is our value. Now what exactly is this value? This part is R. That is minimum of U or R for the second case, absolute of mod x minus 1, and below it is Y. And this part is L for both the cases, and this is plus 1. So this is exactly what we had discussed, and then we are printing the answer. And that's it for the problem D. We can see that in this case, what is happening? First of all, our value of x is 4. So between, and like we can directly see from the rectangle only, right? That is exactly what our formula is doing. Here we'll add up three of them, and then for our value 2, we'll add only this value. Then for 0, we have no value. Then again for 2, we have one value. So in the first case, we added five values. Now for the second case, we have only y equals to 2 as the correct one, and for y equals to 2, we'll add these five values because here x is less than equal to y, like mod x is less than equal to mod y. So in the first case, we got five values. In the second, also we are getting five values. So 5 plus 5 is 10. Similar thing is happening in the second one. Like we have already figured out the entire logic and tested it, right? So let's move on to problem number E now. So E is A plus equals to E. You are given an integer n and m and an integer array a1 to an of length n, where each element is between 1 and m inclusive. The following operation is performed 10 raised to 100 times, so basically it is performed infinitely many times on the integer sequence A. Let V be an integer between 1 and m inclusive, with the fewest occurrences in A. If there are multiple such values of V, take the smallest among them. Then append V to the end of the array. You are given Q queries, and the ith query gives an integer xi. So find the value of A of xi after performing 10 raised to 100 operations. So first of all, let's understand what exactly is happening. So to understand what is happening in the problem, let's take the first test case. So we are given three values, 1, 1 and 2, and our possible values are from 1 to 3. And then we are printing the first eight numbers, right? So let's see what is happening. So our array is 1, 1 and 2, right? So our count for 1 is 2, our count for 2 is 1, and our count for 3 is 0, right? So first of all, a 3 will be added. Now a count of 2 and 3 are equal. So now a 2 will be added. Now again a 3 will be added because it is less now. Okay, this is not 3, this is 2. Now the count of all three of them are equal. So now what will happen? First one will be added. Now 2 will be added, and then 3 will be added. And this will keep on repeating, right? So basically, what are our first state values? 1, 1, 2, 3, 2, 3, 1, 2, right? 1, 1, 2, 3, 2, 3, 1, 2. Yeah. Now, can we just do this? Now, our number of queries are 285 and our queries go up to 180. We can't really take out each value, like, we can't really make an array of 118 correct values, right? So, we can't really do this. We need to find some better way, right? Now, let's say we have a problem and our M is, let's say, 5, right? And our frequency of 1 is C1, 2 is C2, 3 is C3, 4 is C4, and 5 is C5, right? And let us also assume C1 is less than C2 is less than C3 is less than C4 is less than C5, right? In this case, what will be our array? We will have some elements, right? N elements. And what will be our N? Let's draw it down only. We'll have some elements N. And N is C1 plus C2 plus C3 plus C4 plus C5. And we already know the orientation of these elements, right? So if a query asks for any element from 1 to n, we can directly answer it, right? Now since C1 is less than C2, so what will happen? This number will change from C1 to C1 plus 1 to C1 plus 2 and so on up to C2, right? So basically what we are doing is we are adding ones. And how many ones we are adding? C2 minus C1, right? We are adding C2 minus C1, right? Now what happens? The count of 1 and 2 become equal, right? So now what will happen? First of all, 1 will be added and this will become C2 plus 1. Now a 2 will be added and again a 1 will be added and a 2 and so on up to what? C3 and this is also C3. So basically what we can say is that this times twice the difference is added and the elements are 1, 2, 1, 2, 1, 2 and so on, right? Now in the next case again, now we have three values equivalent to C3. So if we want to make all of them equal to C3 plus 1, then it will take us three elements. And we want all of them to be equal to C4, right? So now again, what will happen? We'll have some elements that is 3 times of C4 minus C3 and our 1, 2, 3 will increase like 1, 2, 3, 1, 2, 3 and so on. Then 4 times C5 minus C4 and now 1, 2, 3, 4, 1, 2, 3, 4 and so on. And now what happens? All our elements are equal, right? So basically now what happens? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and so on, right? Till infinite, right? This is basically what is happening. Now what can you observe from this? Let's say like current situation. Smallest value, Ci, its frequency, I times, and second smallest value is Ci plus 1. So basically we are we know that next Ci plus 1 minus Ci times elements are basically what? Patches of I, right? These are I patches, and we have Ci plus 1 minus Ci such occurrence, right? And let's say our values are A1, A2, A3 up to AI, right? And let's say here A1 is less than A2 is less than A3 and so on, right? So basically what we are doing is A1, A2, A3 up to AI, and again A1, A2 up to AI and so on, right? Now when we'll move to the next node. Now after this, actually this is not up to AI, right? This is up to AI minus 1, because we are only considering the leftover values, not the current value, right? Like in this case, we did C2 minus C1. So we only considered one element. Oh yeah, it is fine. Right. Now for the next case, it will be what? Now in the next case, I plus 1th number added, right? And let's say now our cases A1, A2, A3. Let's say some AX, then we have A of I plus 1 and A of X plus 2 and up to AI, right? So in this case, we'll have what? I plus 1 patch, and each patch will have A1, A2, AX, then AI plus 1, AX plus 2, and up to AI, right? This will be in all of them, right? And again, number of such patches, right? So, what we can conclude from this, right? We are given a query and we need to find the element at the xith index, right? Let's call this xi only, right? Now this test case is also pretty long, so it is no point in doing it like this, right? We first need to make some algorithm, right? And we already noticed the element increment, right? It was incrementing like this only. So what do we know? Our first group is from 1 to n. Then our second group is from n plus 1 up to, like what do we know? Our first group is from 1 to n. Then our second group length is C2 minus C1. Our third group length is C3 minus C2 times 2. Then our fourth group is 3 times C4 minus C3. Next group is 4 times C5 minus C4 and so on, right? So basically, can we guess the endpoint? Let's say R is the endpoint. So endpoint is basically for first value it is n, for second it is n plus C2 minus C1, right? And so on. And what is the last value? 180, because that's still where our query is going. And definitely Ri is nothing but Ri minus 1 plus Ci minus 1, right? Because this was the first value, this was the second value, so it was Ci minus 1. And similarly, our Rn minus 1 is nothing but Rn minus 2 plus what? Cn minus 1 minus Cn minus 2. Or actually, what we can say is that actually, let's say that the first value is 0, right? Because then it will align properly. Let's say this was the 0th value. So this was the first value, right? So in this case, we have what? I plus, let's write this again. Ci plus 1 minus Ci, right? Then in this case, we have R of n minus 1 as Rn minus 2 plus Cn minus Cn minus 1, right? And we know that R0 is nothing but n and Rn is nothing but 118, which is basically infinity for us, right? And similarly, R1 is also nothing but R0 plus C2 minus C1, right? So basically, we can find the endpoint. Now we have some R vector, right? And this is in increasing order. I mean, definitely it is in increasing order. So now what we can say? We are given xi. Now with this, we can find which group xi belong to, right? And how? What we can do is, what will happen if we do a lower bound? Let's say we do a lower bound and we get the our value is, let's say, less than the value of the third R3 and greater than R2. So a lower bound will point to R3, so it will tell us that it is in the third group, that is between R2 and R3 one, right? That starts from R2 plus 1 up to R3, right? And let's say if our value was R3 only. In that case also lower bound will match to that only. So basically what we can say is that it is nothing but lower bound of our R vector, that is R dot begin, R dot end, and what, xi, right? Let's just do the whole thing minus lower bound, sorry, right? So basically what is this? This is index in that group, right? And what is group I? You have already noticed what are the groups, right? This is our 0th group, this is our first group, this is our second group, this is our third group, this is our fourth group, right? So ith group first of all repeats I times, right? And it has all the values from 1 to I, right? So group I is nothing but A1, A2, A3 up to AI, right? and let's say this is 1 and same thing is 2 and this is repeated what? Ci plus 1 minus Ci times, right? So basically, since it is repeating only there, so if we take index, right, this was equal to index. If we take index modulo I, so points to first element of the group, right? Not the first element, but the first part of the group, right? This basically points to 1. And now this index, actually, yeah, it just does point to the element, right? It does point to the element of the first group, right? Right. So we are given a xi, and you also know that if xi is less than equal to n, then our answer is like a of xi, right? This is our input. And else then we are finding which group it belongs to. Then we are taking the modulo with I, and then we are finding the element, right? So this gives us the element. Now we can see that how many groups do we have? We have basically n number of groups, right? Or 0 to n, we have n plus 1 number of groups, right? So what we can say is number of groups n plus 1, or it is better to say n because the zeroth group is not triggered, right? Because in case of zeroth group, we have a different condition. We are directly printing the answer, right? And then lower bound is log n, right? And this is q times at max, right? So it is O of q log n plus n type of complexity, right? And after this, what is happening? We get index, then we do index modulo I, and this gives us element. Now the thing is how we will find this element. Isn't this pretty simple? We know which all values will we have, right? We know we have values A1 up to AI, right? And so Let's say our final index is j. So we need the jth element when it is sorted, right? So how we can do is just use set, and whenever like we know we are on the ith one, right? So when we are on the ith one, we take the first I values, like we just keep increasing the values and keep appending them in set. And now we need to find the element, but the set does not work right this, right? So instead we need to use ordered set so that we can use the index also, right? So this is basically the logic for the problem is. So let's discuss the code now, right? So first of all, I've included the files for the ordered set, that is these two files, and the namespace for it. Then I made the template for the ordered set. Now the main code is that we have taken the input. Then I have taken calculated the frequency of each element because this is what we need, right? And now I've made an index array for this, and then I've sorted all these values, right? That is my index of I tells me like which of these frequency I need to pick up, right? And now I stored the right endpoint for each of them. That is nothing but f of index of I minus f of index of I minus 1. This is exactly what we were doing. And yeah, here it is. C of I plus 1 minus C of I minus 1. This is nothing but the same thing here, right? And the last value is 180. Now we can notice that we have created this, we have kept the indices one like one base, right? That's why we are getting I and I minus 1. Here the indices were 0 base, that way it was I plus 1 and I, right? And this doesn't really matter, it depends on how you implement it. The logic remains the same, right? Now our initial value was n and our last value is 118. Now we have taken the queries and we have made an answer vector. Now, what exactly is this answer vector storing? Right. This will store us the final answer, obviously. We have made a vector of pair. Now, what is this doing? We'll see this. We are taking the input. If our this x value is less than n, then we are directly storing the answer. Else, what we are doing is we are finding the group. It belongs to the kth group. So I am appending this value into it the kth group. Now kth group, like there can be multiple numbers, right? Which technically belongs to the same group. So I'm storing all these numbers, and this is exactly what I'm doing. I found the group. I am taking its right endpoint and I'm subtracting it. Right. This is what we were doing, right? Where was it? This is okay. We missed a part. This is index of group. Right. Let's do this here. Yeah, we had R, right? Right. This is the index. So R of index This tells us the like rightmost boundary of the group, right? And this is a group. This value is R. This was the previous group, like Ri minus 1. This was Ri. And this value is Ri plus Ri minus 1 plus 1, right? And we have some value x here. So we need to find this. We are interested in this index, right? So basically, my j is nothing but this x minus what? How we'll get this Ri minus 1? We will get this by R of index minus 1, right? And then we'll increment 1 because the first value is Ri minus plus 1, right? And this is our 0th value. So this gives us the index, right? And then we do j is j modulo I, right? Actually, again, this is the group number, right? So this is j modulo index. We were on group K, so we are doing modulo with K, and this is exactly what we are doing. So this is giving us the like the offset, you can say, or the index of the element. This is our j value, right? And I is telling us like the query number. So we are storing this pair in the group, right? Now for each of them, we have stored this value. Now we have made a ordered set, and now we are doing a loop on the number of groups. Now after each loop, we are inserting the value of the previous group, and now what we are doing is in the group we are storing the our offset and the index of the answer. So we are putting the index of the answer depending on the value, right? As find by order pretty much gives us the value we need, right? We needed the ith index when it is sorted. So now this is the ordered set, which is basically a set only, right? So it is sorted first of all, and find by order is pretty much telling me that give me the like gives the xth element in the set, right? This is exactly what we needed, and this is our answer. So basically, we are doing this for all the values you have stored in this in these groups, and then we are printing the answer. So the main key to this question was that figuring out the size of each group and the fact that each group is just a multiple of some small numbers repeating again and again, right? So we could guess the length of each group. Then from the length of each group, we can guess that it's starting and ending point, right? Now we have stored the ending point. Now after storing the ending point, what we are doing is we are able to find the group in log n complexity instead of the whole linear search. We can find it directly using lower bound. And once we have gotten the group, we can get that offset value, and then we are doing the modulo by k because that same value of numbers are repeating again and again. And once you have done this, now as we are moving from group 1 to group 2 to group 3, we are adding one element and placing them in set, and then we are finding that specific element which we need, right? So this was basically the crux of the E problem. I hope you would have understood the question. So this is it for our discussion. We have discussed problem A to E, and that's it.